Hey everyone, this is week 3 of cycle 2 and we're looking at a AS pure paper again. So the first question really is about knowing function notation. So we're used to seeing f of x and so on, and this function notation says that the name of the function is f, that it is a map, so a map is just a correspondence between two things. So it's a map between x and some f of x, where f of x is equal to 3x plus 2. So that's what this notation means. This little weird arrow means you're talking about a specific x that someone has given you, and you're mapping it to 3 times that x plus 2. And it is defined, the domain of these functions are the real numbers. That's what this means. You would say this out loud as x is an element of the reals. So this is not defined for complex numbers. I cannot go to this function and hand them a complex number or something, or a vector or an apple or something. It doesn't know what to do with that. It only knows what to do with real numbers. So the first thing you need to do is work out this thing on the left-hand side. So this is the inverse function of x. So the idea is that I would give you 3x plus 2, and you would give me back the x. So I'm going to give you something that I'm going to call y, and you've got to work out how to extract x from that. So let's say, so we've got f of x is equal to, I'm going to call this y, and that's equal to 3x plus 2. So this means that if you rearrange, you'll see that x is equal to 1/3 y minus 2. So the inverse function, f minus 1, and I'm just going to call y, I'm just going to relabel x and y. I mean, they're just variables, right? They're just standing in for something. F minus 1 of x is 1/3 x minus 2. And when you see two function names together, that just means it's g of f of x. So g, and the argument of g, as in the thing I'm giving it, is the whole function f of x. So wherever you see x in this g, you put the whole of f, which is 3x plus 2. So they're telling us that these two things are equivalent. They're telling us that 1/3 x minus 2 is equal to g of x, that's 4 times the whole of f of x, which is 3x plus 2, minus 12. So if you multiply through and you rearrange, you can get a value for x. And that's all that is to it. So it's just about knowing this function notation and how to get the inverse function from a function, this relabeling thing. Okay, so this one's about the binomial expansion. So you've got some bracket raised to an integer power, and the full expansion is going to have 7 terms, and it's going to, 8 terms, and it's going to have coefficients that are like these factorial functions, which are it's all given in the formula booklet. So you don't want to really write out all 8 terms. You're told that the coefficients of x to the 4th and x to the 5th are equal. So the function is going to look something like, x to the 7th plus 7 choose 1, x to the 6th times 2k, plus 7 choose 2, x to the 5th, 2k squared, that's one of the terms we want, plus 7 choose 3, x to the 4th times 2k cubed, plus, and then so on for some more terms. So they're telling you that the coefficient of this term are the same. That means whatever's in front of the x bit. So we know that 7 choose 2 times 4k squared is equal to 7 choose 3 times 8k cubed. And then this is just like crunching it into the formula for the choose combinatorics. So it'll give you that 84k squared is 280k cubed. And you just divide by k squared, and you get that k is equal to 3/10. Okay, so here's one with a big fancy diagram. Initially, it might look intimidating, but don't worry, it's actually pretty simple. So they want you to talk about the volume of water in this tank. So you see that, so it's been a bit obscured, but there is some level at some stage, and it's filling up. So this level is getting higher and higher, and it's filling this prism all the way through this trough. So if we want the volume, which is what they're asking for, we're going to have to just take the area and then multiply it by the length of this trough. That's the volume of this sort of like sub-triangle that's sitting in there. So firstly, what's the area of this triangle? Well, if I divide it in half, I can see that this side is just h, which is what they're given, the depth of the water, h. This is going to be 30 degrees again. And this is going to be 60 degrees. Simple. So we can see that the tan of, say, 60 degrees is opposite. So let's call this side is 1/2 of the base. Is this side of the triangle, right? So the tan of 60 is opposite over adjacent is going to be 1/2 of the base of the triangle, by which I mean the base of the whole big triangle, all over h. And we know what the tan of 60 is. It's just square root 3. So if we rearrange this for b, we get that the base of this big purple triangle is 2 square root 3 h. Okay, so that means that the area of the purple triangle is just 1/2 times base times height. So it's going to be square root 3 h squared. And then we see that in the diagram, they tell us that the sort of length of the trough is 40 centimeters. So of course, the volume is going to be area times that length. It's going to be 40 square root 3 h squared. Now they want us to find the rate at which h is increasing when h is equal to 5. So the information we're given is that the volume is increasing at 200 cubic centimeters a second. So we know that dV dt is 200. Now if we use the chain rule, we can see that this is equal to dV dH dt. And we can get dV dH. dH dt is what we want. That's the rate that it's increasing. We want dV dH dt. So we need an expression for dV dH. But we can just get that from the one we worked out before, right? So that's 80 square root 3 times h dH dt. So therefore, we have that dH dt is 200 over 80 square root 3h. And now they're telling us so that this is a rate which is going to depend on what h is at the time. So we're going to want to evaluate it at this value of h. So dH dt evaluated at h is equal to 5 is just equal to, if you put it into your calculator, you'll get something like 0.289. Okay, trigonometric identity time. We all love these. So I'm just going to write the shorthand that sine is just s and tan is t and so on. So I'm going to write it's 1 over s minus 1 over t, all squared. Now we know that tan is equal to s over c, right? So I'm going to turn that into all sines and cosines. So 1 over tan is therefore cosine over sine, all squared. Now I'm going to draw this all together into one fraction. So that becomes 1 minus c over s squared. Sorry, over s, all squared. So this is 1 minus c squared over s squared, and sine squared is just 1 minus cosine squared. Oops. Like that. So we've got these two expressions. So now I'm going to resolve these into two brackets. So this is going to be one. This is just 1 minus c squared. So it's just two copies of it. But the trick is to realize that this thing can be decomposed into two brackets, one with a plus and one with a minus. And you can convince yourself by remultiplying it that you'll recover that original thing. But now I can cancel this. And so I'm left with the thing that they required, 1 minus c over 1 plus c. So now they want us to equate that to 2/5. So we have that 1 minus cosine is equal to 2/5 times 1 plus cosine, just taking the thing over. And so this implies that the cosine of x is equal to 3/7. And if we look at our cosine function, 3/7 is, I don't know, around there somewhere. And it's also around here. So, I mean, so if this is, remember, this is just the cosine of x, and that's x. So there's two values of x within this range, 0 to 2 pi, because that's 2 pi. That's pi. There's two values of x which will give me the correct cosine. So the calculator will give me that x is equal to, this is what I call my x naught, is equal to, let's do it in radians, 1.13 radians or thereabouts. But then I have to remember that x1 is equal to 2 pi minus x naught. Because if you look graphically, this length is x naught, the distance from 0 to x to the point x naught. And that's the same distance as between x1 and 2 pi. So if this is the point x1 and this length is x naught, so x1 must be 2 pi minus x naught, which is, I think, 5.16 radians. And then you require both of those answers to get the full marks. Okay, we've got this these sectors here. So first you want us to show that this length OB, so essentially the radius of this slice, is 7.27 centimeters. So what can we say about we know that it's the hypotenuse of this triangle, we've got an angle, and we've got one of the sides. So that's all the information we need. So that's hence why this is such a only a 1 mark question. But we say cosine of 0.6 is adjacent over a hypotenuse, so that's 6 centimeters over OB. And so that means that OB is, if you just rearrange, is 7.270 centimeters. Now they want us to find the perimeter. So what do we need for the perimeter? Well, we've got this bottom side, no problem. We know that this side is going to be OB sine of 0.6. We've just found OB, so that's no problem. We know that this height is going to be, because it's the radius of this the sector, it's going to be the same radius as OB, so this is also same as OB. And then this is an arc length, which means that it's going to, so if it's subtended by this angle, which is pi on 2 minus 0.6, remember we're in radians now, so 90 degrees is pi on 2 minus 0.6, so that means that this length is the radius, OB, times the theta, the angle subtended, times pi on 2 minus 0.6. So the perimeter is therefore OB, which is the one that the side that, not OB itself, but the one that was equal to OB, plus OB pi on 2 minus 0.6 plus OB sine of 0.6 plus 6, which is 24.4. And now they want us to find the area, and that's pretty simple as well. So the area of this guy is going to be 1/2 times the base times the height, so that's 1/2 times 6 times OB sine of 0.6. And the area of this guy, well, it's in the formula booklet, is 1/2 times the radius, which is OB, times, the radius squared, OB squared, times theta, which again is pi on 2 minus 0.6. Oops, sorry if that was noisy. So the area is going to be equal to 1/2 times 6 times OB sine of 0.6 plus, well, we just went over this. So this is equal to 38.0 centimeters squared, if you want to be fully correct. Okay, question 6, vector question. So we've got given these 3 points, and we're told that the line from A to B is equal, has an equal length with the line from B to C. So the line from A to B, well, that's just B minus A, right? We've been over why that's the case. So that's equal to 8 minus 6. And that means that the mod of it, the length of it, is square root of 8 squared plus 6 squared, which is equal to 10. In fact, let's just take the squared. So the mod squared is that, so that's equal to 100. And now BC, which is C minus B, is equal to minus 6 and K minus 1. So that means that BC mod squared is 6 squared plus K minus 1 squared. So these two things must be equal, because if AB is equal to BC, then AB squared is equal to BC squared. So we have that K minus 1 squared is equal to 100 minus 36, which is 64. So we take the square root, we get K minus 1 is equal to plus or minus 8. So therefore, either K is equal to 9 or K is equal to minus 7. Okay, so now they're supposing that there's a perpendicular bisector of AB. So if the thing is perpendicularly bisecting, then it's going to have it's going to hit AB at its midpoint M. So we're going to find that first. So midpoint of AB. Remember, to get to the midpoint of AB, I need to go to A first, and then I need to go halfway along the line A to B. That's how I get to M. So that's equal to 1, 4. So the other thing is that the gradient, remember that the perpendicular, something's perpendicular means the gradients multiply to minus 1. So I want the gradient of AB so I can get the gradient of the perpendicular bisector. So the gradient of AB is just going, delta y over delta x, change in y over change in x. So it's minus 6 on 8. And that's equal to minus 3/4. So therefore, this means that the gradient of the perpendicular bisector is 4/3. So this means that so far my equation for the perpendicular bisector looks like y is equal to 4/3 x plus c. I plug in m, and because the m is obviously on this line, and I get that 4 is equal to 4/3 plus c, which means that c must be equal, of course, to 8/3. So y is equal. So now I've got that y is equal to 4/3 x plus 8/3, and now I'm looking for the x intercept of d. So that's when y is equal to 0. So that means 0 is equal to 4/3 x plus 8/3. And you see that this means that x is equal to minus 2. And of course, it's the x intercept. So that means y is 0. So d has the coordinates minus 2, 0. Okay, more vectors, 3-dimensional ones this time. So we're given 3 vectors, one of which has these variables, and we're going to look at some different cases for the variables. So in the first one, they're telling us that ABC is a straight line. So you start at A, there's the vector AB, which will take you to B, and then there's a vector BC, which will take you to C. And if it's a straight line, it means that the vectors are all parallel, or these 2 vectors are parallel. And if two vectors are parallel, then you can talk about the one vector as just some number times the other vector. So we know that AB must be equal to some number k times BC. So if we work out what AB is, we get that it's 2, 3, 1, and that's equal to k times 1 p minus 5 q plus 2. So remember, this is a vector equation, so we can look at each like line, you know, all the x component of this equation, the y component and the z component all separately. So the x component gives us that 2 is equal to k. So, you know, k is equal to 2. Then we have the y component, so 3 is equal to, and I'm going to plug in what k is, which is 2. I got 3 is equal to 2p minus 10. And then in the z direction, I've got that 1 is equal to 2q plus 4. So if I solve this first one, I get that p is equal to 13 on 2. And the second one gives me that q is equal to minus 3 on 2. Okay, so now we're looking at a different case, and they're saying that the angle BAC is 90 degrees. So that means that the angle BAC is the angle between AB and AC, right? So if that's A, that's B, and that's C, then the angle BAC is going to be where AC and AB cross. So obviously we're going to need to talk about a dot product here because we're talking about the angle between them. Remember that the dot product is 0 if the angle between them is 90 degrees. So we have the dot product between AB is 0. So let's look at what the dot product is. Well, AB is just 2, 3, 1, as we had before. And if you look at AC, that's just C minus A, you'll find that it's equal to 3 P minus 2 Q plus 3. And remember, you know, P and Q are now free agents again. We've left that first case behind, and we're looking at a different case. So P and Q are going to be different. So this is equal to 6 plus 3P minus 6 plus Q plus 3. The 6's cancel, and you'll find that Q is equal to minus 3P minus 3, because this whole thing is 0. Okay, so now they're telling us that in another third possible case, P is equal to 3, and they tell us the length of AB and AC are equal. So again, so we know that AB, the length of AB is the square root of 4 plus 9 plus 1. And they're saying that this is equal to the length of AC, which in our case, if we plug in the fact that P is equal to 3, we still don't know Q. This is going to be square root of 9 plus 1 plus Q plus 3 squared. And I'm going to square both sides of this, and I'm going to get that 14 is equal to 10 plus Q plus 3 squared. If I take that over there and then take the square root, I get that Q plus 3 is equal to plus or minus 2. And therefore that Q is equal to minus 1 or minus 5. Okay, question 8. Another question with functions. So you should be like completely au fait with this functional notation now. The domain of f is the reals, as usual, and f maps some element x of the reals to the element x squared plus ax plus b. So in the first part, they've given us, they seem to be a big fan of this in this question paper, where they give you something in terms of these little variables and then look at different cases. So the first case, a is 6 and b is minus 8. So that means that f of x, let's try that, f of x is equal to x squared plus 6x minus 8. And they're asking us to find the range. So the important thing to realize is that this thing is a parabola. And it's a smiley parabola. It's like, oops. It's like so. So there's going to be some minimum value that can be that this parabola can produce. Like as you vary x, as you come in from minus infinity, and x approaches some value, the y that you get is going to be moving down. It's going to hit some minimum value, and then it's going to start heading up again as you increase x. So to find that minimum, I'm going to differentiate. And there are many ways to do this question, but calculus is always the quickest and easiest way. So df dx is 2x plus 6, which is equal to 0 when x is equal to minus 3. And when x is equal to minus 3 at this minimum point, what is f of x? Well, f of minus 3 is just 9 minus 3 times 6 minus 8, which is equal to minus 17. So that means that the range of f is greater than or equal to minus 17. Another, just like a little tidbit for you, if you like mathematical notation, you could also say that f of x is an element of the set minus 17, comma infinity. But yeah, don't worry about that if that scares you. I think I got those brackets right. You know what? I might have even made a mistake with the brackets. I actually can't remember which way around they go. The soft and the hard brackets are talking about like whether you include minus 17 or not. And I think that means you do include it. I'm pretty sure. Yes, but I could be wrong. I think there's a soft one around infinity because you can't ever include infinity because it's not a number. But I could be wrong in that. Okay, so part 2. So now we've got a different case. A is equal to 5. So f of x is equal to x squared plus 5x plus b. We still don't know b. And they're telling us that the roots of this quadratic are k and minus 2k. So that means that f of x can be written as x minus k, x plus 2k, which is equal to x squared plus kx minus 2k squared. And so we can identify that k is equal to 5 and b is equal to minus 2k squared. And if you plug in the value of what k is, this gives you minus 50. Okay, last case. Everything's general again. We're not told what a and b are, but we're told that the equation f of x plus a is equal to a has no real roots. So f of x plus a means that wherever you see x, you plug in x plus a instead of x. So it's x plus a squared plus a times x plus a plus b. So if we multiply this out, we get that x squared plus this, 3 copies of a, x plus 2a squared plus b. And this is all equal to a. That's what the equation is. So that means that our quadratic that we had to solve is x squared plus 3ax plus 2a squared plus a plus b. And we're told no real roots. So that means that the discriminant, del, which is, b squared minus 4ac, not the same b and a that are here, but the coefficients in the equation. And that is therefore less than 0. So if it's less than 0, it means your roots are going to be complex, going to have imaginary parts, because you're going to be taking the square root of a negative number. So we know that if there's no real roots, then this thing is true. So we have b squared, so that's going to be 9a squared minus 4 times that coefficient, which is 0, times 2a squared plus a plus b. And we see that, and this is less than 0, and this is equal to 9a squared minus 8a squared, so that's a squared minus 4a plus b is less than 0, and then you just take this to the other side, and you will get the solution. Question 9, integration. So this is just about integrating a few times and keeping track. So we're given the second derivative of the function, and we're given a fact about it, and we know that a stationary point means that f prime at the stationary point is equal to 0. So we're given these two facts. And the first job is to integrate once. So f prime prime of x is the same thing as d dx of f prime of x. So you got the first derivative and you're differentiating it again, gives you the second derivative. And this is equal to 12 on x cubed. Separation of variables. So df prime is equal to 12 over x cubed dx. I'm going to integrate this. We get that f prime is equal to minus, how to do this, minus 12 over 3, over 2 x squared plus c. And you see that, it's because if I differentiate this thing, I'm going to get a minus 2 coming out, so I need to account for that. And we know that this is equal to 0 at x is equal to 2. So f prime at x is equal to 2 is minus 6. So this becomes 6. Minus 6 on 4 plus c is equal to 0. So that means that c is equal to, I'm going to call this c1 suggestively. c1 is therefore equal to 3/2. So that's all very well and good. That gives us f prime. So this thing gives us that f prime of x is equal to minus 6 on x squared plus 3/2. But we want f of x, so we have to differentiate again. So we have that df dx is equal to minus 6 on x squared plus 3/2. So that means that if we integrate this, we get that f is equal to integral of minus 6 on x squared plus 3/2 dx, which is 6 over x plus 3/2 times x plus c2, another constant of integration. And then we can use the fact that this is also a piece of information that this point lies on the curve, because f is just y, right? So we know that 10 is equal to f of 2, like the original function evaluated at 2, not f prime. And that's equal to 6 on 2 plus 3 plus c2. So this gives us that c2 is equal to 4. And so finally our f of x is equal to 6 on x plus 3/2 x plus 4. So this was step 1. This was step 2. Now they want us to find the coordinates of the other stationary point. So stationary point, remember, just means that f prime is 0. So we just take our f prime minus 6 on x squared plus 3/2, and that's equal to 0. So let's multiply everything through by x squared. We get minus 6 plus 3/2 x squared is equal to 0. So x squared is equal to 4. So x is equal to plus or minus 2. So we already looked at the minus 2, the plus 2 case. That was the one we were given. So now we want the minus 2 case. So we're going to look at just what the y coordinate is there. And so that's f of minus 2 is equal to minus 6 on 2 minus 3 plus 4, which is equal to, should be minus 2. So that means that the other stationary point is the point minus 2, minus 2. Now they want us to find the nature of these stationary points. So of course, what that means is looking at the second derivative. So f prime prime is what we were given in the first place, evaluated at plus 2. is 12 on 2 cubed, and you can already see that this thing is greater than 0. So therefore, this thing is a minimum. And f prime prime of minus 2, well, that's 12 on minus 2 cubed. And because it's a cubic thing, if you square it, the minus sign will go away. Because it's cubic, the minus sign will come back. There's going to be minus 12 on 2 cubed, which is less than 0. So this is therefore a maximum. Okay, question 10, last question. Sort of integration in bits, integration, differentiation. So the first thing I'm going to do is I'm going to differentiate this, and you'll see why. dy dx. So that's going to be equal to 1/2 times 1 over square root of 9 minus 2x squared times the derivative of what's inside, which is minus 4x. So that's equal to minus 2x over square root 9 minus 2x squared. Okay, that's just some bookwork that'll be useful in a second. So show that B is the midpoint of AP. So we want to talk about how it hits, well, firstly, it's the normal to the curve at P. And so that means that its gradient is going to be sort of minus 1 over the gradient of the curve at P. So dy dx evaluated at P is minus 2 times 2 over square root of 9 minus 2 times 4, which is equal to minus 4. So that means that the gradient, the gradient of AP is therefore equal to 1/4. So our current equation stands at y is equal to 1/4 x plus c. Plug in the point P, and we get that 1 is equal to 1/2 plus c. So c is equal to 1/2. So our equation, amended equation, is y is equal to 1/4 x plus 1/2. And now we want the x-intercept, so that's when y is equal to 0. And that'll give us 0 is equal to 1/4 x plus 1/2. And that gives us that x is equal to minus 2. So the coordinates of A are minus 2, 0. So we're halfway there. The coordinates of B are when x is equal to 0. So we have y is equal to 1/2. So that means that B is equal to 0, 1/2. Okay, we're almost there. This is, again, there's several ways of doing this. So this is only one way. If you have a better way, please share it on the boards with people, or a quicker way, or just a different way. And I'm just going to do it the way that makes most sense to me. The way I think about these things is usually in terms of vectors, because vectors are great. And so I'm going to look at the vector AP. Well, that's just equal to P minus A. And that is equal to 4, 1. So the midpoint is A plus 1/2 AP. And that's equal to 0, 1/2, which is equal to B. So that's shown. So the first thing was to find A, then to find B using this one method, and then to find the midpoint of AP and show that it was equal to the same thing as B. Now they want us to do a volume of revolution. So the big equation to remember for this is that the volume of revolution is equal to pi integral x squared dy. So the trick is to express x in terms of y, so we can do this integration. So we're choosing to go x squared dy. You might have seen ones with y squared dx. It's all about where your limits are and like which axis you're rotating around. So we're rotating around the x-axis between, and the region we're interested in is between two y limits. This y is equal to 1 and wherever this point is. So let me find this point first. So this point happens when it's a point on the curve when x is equal to 0. So y is equal to 3 there. And there's this point, y is equal to 1. And so we want to integrate over y. So the first thing is to express this equation here. So y is equal to square root of 9 minus 2x squared. Express this as x as a function of y. So here we have that y squared is equal to 9 minus 2x squared. And you see that x is therefore equal to 1/2, x squared rather, because we're using x squared anyway, is equal to 1/2 times 9 minus y squared. So the volume is going to be equal to pi times the integral, and the limits are 1 and 3, as we've just seen, dy of 1/2 9 minus y squared. And you know, it doesn't actually matter where you write dy at the beginning or the end. In A levels, I think they prefer, well, they tend to write it at the end, but you can write it at the beginning as well. Don't write it in the middle, just write it on one side of your integrand, the thing you're integrating in. And if you let's write that, so it's pi over 2 times 9y minus 1/3 y cubed between 1 and 3. And you'll find that that becomes 14 over 3 pi, which is, or 4 2/3 pi. And that is the solution. Okay, I think we've reached the end of the paper. So I hope you found this helpful, and I will see you next time.